EPO. But trying to make a few conclusions just from the legal provisions I just presented to you. The first thing is that's a general understanding in Europe, differently, for example, from the United States. That dimension has to be technical. Whatever that means, there's a lot of dispute, especially in the United States. What does it mean? It's very simple. Technical is everything that is somehow, well, I'm a physicist, subject to physics, something that you can detect, that is solid, or any physical phenomenon, including signals, by the way. We have, as a corollary to this, we don't have coded provisions, but a very general understanding that a patent-level invention is more than only consisting of non-technical features. So just the mere fact that there is something physical, something detectable, something tangible, that's not enough. There has to be more in it. And the key phrase we sometimes hear, which, if you look at it, is not entirely correct, is that UCCT cannot be patentable. Now, as I said, this is not entirely correct. If you wish, we can go into this discussion. But it shows the mindset, illustrates the mindset in Europe. And then we have a further limitation. I told you we have an exclusion, and we have an exclusion from the exclusion, but still we have an exclusion. Which means whatever we do in terms of case law, in terms of patent practice, we always have to do it in a way that this exclusion is not reduced to nil. That is, there has always to be some kind of subject matter that we do not patent. And what that is, that's actually still is in some regards an issue of dispute. Now, how does the EPO handle this? And in fact, that can be summarized into seminal decisions, which were actually basically made by Mr. Steinberg, who's now also mostly sitting at the podium. He actually made this law. The first was the Hitachi decision, which basically said, well, you remember this exclusion of business methods, computer programs. Well, you avoid this exclusion if you have at least one technical feature in the claim. And that feature can be something as trivial as a computer, a network, or putting it to the extreme, it could even be, as the board mentioned in this decision, could even be just pencil and paper, as long as it's an element of the claim. And that was a point of discussion at the time, whether for both method and apparatus claims. Now, you remember I said, well, an invention cannot be just something that has just some technical features. The invention has to be more than just having non-technical features. And that the Board of Appeal took care of by shifting this issue to the examination of inventive step. So that's where they ultimately assess, do we have something technical, and what is technical, and what of it is inventive? And the key phrase that you should memorize from this session is, for the inventive step, you only consider technical solution to a technical problem. If you don't have a technical problem, or something that doesn't solve a technical problem in the claim, you drop it out, and even if you solve a technical problem by non-technical means, this is also not considered. So we need two things, a technical problem and a technical solution, and that's only what you look at, and you forget everything else. I may say, well, how can it be that you solve a technical problem by non-technical means? Give a very simple example. If you're running a telephone network and you experience periodic overloads during the day, there's a technical and a non-technical solution to it. The technical solution is you enhance your network, make it stronger, you introduce more capacity. And the non-technical solution is simply that during the peak hours who make telephone calls more expensive. So people shift telephone calls to the evening, and only those who must do that during the day. Which solves a technical problem, excuse me, because ultimately, very measurably, very detectable, the telephone network is no longer overloaded, but it's solved by non-technical means. And in consequence of this approach, the first thing you do is, and that's sometimes a controversial issue, you identify what's technically in the claim. Now, if you take the first good business method, you don't consider the business method. You only consider the computer, what it's doing, its operation, even if it's phrased in non-technical terms, or even if this is implicit, and that's also sometimes a bit for the prosecution before the European Patent Office, because naturally you phrase technical subject matter in non-technical language just because it's more intelligible. If we're talking about text dumps and hexadecimal formats and that kind of thing, I think most people would throw up their hands. So, for example, when you talk about storing something on media or outputting stuff from media, we talk about reading and writing, which is natural language. But of course, everybody is aware that this is not some little green man writing something with pen and paper, but it's something technical that's happening inside the computer. There may even be a technical character in certain features if you adapt certain things, especially for a computer, if you modify a business method so that it can be especially adapted in a computer. And then what we do is we determine a technical problem, as I mentioned before, and we determine how this is solved by technical features that we have identified, and that is now, and that's the beauty of it, now we have ended up in the normal examination of the repetitive step. You may be aware that for the EO we love the proper solution approach, and we know how to do this. And as soon as we've identified the technical features, it's a straightforward examination of the claim as in any other field of technology, just limited to the technical features. Now what happens to the non-technical features, especially when you're doing business-related applications? We find a lot of language in the claims, method for stock trading, stock market price going in there, sales orders going out there, and that kind of thing. Well, first you have to isolate these non-technical aspects, as I would call them, because sometimes features have both technical and non-technical content, and this non-technical aspects you can use for the definition of the problem. Remember, we have the proper solution approach. We find a problem, and then we ask for the solution of this problem, because by definition is obvious. And now you would ask, for example, given a possibly new method of stock trading, and this is supposed to be known to the person skilled in the art, would the technical implementation that is claimed be obvious for the person skilled or not? And if it's nothing more than saying, well, this new method of stock trading implemented on the computer, then the immediate reaction of the European Patent Office would be, well, you can implement anything on a computer that you can phrase as a method or an algorithm. And as long as you don't make any limitations how and how quickly and with what capacity of computer, it's just not a solution. Just if it's just any implementation. If it's a specific implementation, that's a different story. So, summarizing, we have two hurdles. The first is very low. You can almost by boilerplate language set over it in that as soon as technical means are specified in the claim, you have passed this hurdle already, and then we have set a second hurdle which is much higher, in fact very highly sometimes in practice. That is a better step, where you only carry out an explanation limited to the features contributing to the technical character. Now I'll illustrate this with a very simple example. Let's say you have a method of collecting fees for downloads from a server or from the internet based on a geographical location. You distinguish for the geographical location because people in India or in Africa should pay a little bit less than people in Germany or in Canada or the United States. That's just a business method. If the claim is just like this, it's straightforward, not patentable, because there are no technical means recited. Now, if I amend this a little bit and say, well, I use a computer, there is no longer the exclusion under Article 52.2, but you have no technical problem that solves all the problem is simply trivial. If you look more closely at the claim, it doesn't say what you use a computer for. It just says, I have this method, and somewhere I use the computer. The computer could even be used for voice over IP or whatever. And if you just use a computer while using a computer in any modern method, be only for telecommunication, is an obvious thing. Now, if I further enhance the claim and have a GPS system that I use for determining the location, then it really gets more interesting. Then we really have a technical problem because we determine the geographical location by technical means. And we solve this problem by GPS and computer. Now, probably throwing in GPS will not be sufficient to make it obvious, but now we are in the realm of normal explanation, then we look at the prior art. Was there anything that is close to suggested using a GPS for such a method, and then the explanation goes on as usual. Now, we have had about 20 years, or 15 years of case law under this doctrine, and we have a few categories that are more or less safe harbors. So basically, you never have a dispute about exclusion even if a computer or a program is involved. First is what I would call post-computer process activities. That's the control of technical process or machine by means of a program computer. You control an ABS brake, or you control the production line, whatever. Very standard. Next is the reverse. You have a technical device, and the output is hooked up with a computer, typically sensors. You may have some raw data which you process to get refined data. That's also not an issue at all. And then there's a big category, and that's where it gets interesting, which in itself is accepted that as being a technical problem that's generating a new way of operating a computer or a network. So you do something that's related to the operation of a computer. Big dispute sometimes when this happens and what it means that change the operation of a computer. But let's leave this aside. Or with network for that matter. And you have such obvious things as hardware, architecture, which would be the basic commands. You have firmware biased operating system, that's not an issue at all. Network protocols, neither. Then the thing that always surprises me, but it's generally accepted, it's computer and network security, although when you think of encryption algorithms, it's pure mathematics, but well accepted as solving a technical problem. So if you wish, here you have an example where a non-technical feature, when implemented on a computer, has technical character. Then you have manipulating or providing control data. Control data are data that tell a machine what they should do, for example. If you look at this PowerPoint here, there are content data, which says categories of pattern with subject matter, and there are control data, which tell the computer when to switch to a new line. There are user interfaces, which is controversial, because some people believe there is no technical problem involved, and sometimes there's really not. Sometimes there is. But this gives you an idea about the safe harbors, and then there is the big unknown, if you wish, the IC, and that's application software, especially in financial Cs, and then you have to go back to basic principles, argue technical problem, argue technical solutions, and so forth. To finish, I would just illustrate how you navigate on the IC. I refer to two decisions. The one some people of you here may have heard of. They may have heard of the case, not of the decision. That's the famous Amazon one-click, which was not disputed at the time. And people are all saying it's this one-click feature that's not patentable. In fact, it is not really, but that was not the issue, because when you looked at the claim, you have a user identifier stored, namely a cookie, stored on the user's device, and this cookie was used to store, to retrieve pre-stored user data. So there were two things. You had all the user data, which you didn't want to communicate over the internet for security reasons, or preferred not to. You had that stored on the server, and in order to tell the server which data you now want to access, or to which person you wanted to make an order to, you had this cookie that had an identifier which was set over. So very compact, and we have a technical problem here. As the Board of Appeal phrased it, we reduced the amount of sensitive information sent over the internet and the amount of user data. Now this was a one-click. The patent was granted by DPO. There was, as far as I collect, not a serious issue once people focused on the technical subject matter, and it was revoked in opposition, but not because of Article 52, but because somewhere there was a line in some article with some pseudocode, a comment line that said, oh, by the way, we could also store the user data on the server, and that killed the patent. So it was prior art. The second I like very much because you would initially say, when you talk about a computer game, that's not definitely something non-technical. In fact, programming a computer game is not itself, it's highly technical. In this case, there was the problem that you wanted in a game rotate a character, and there are two things. First, how to rotate it in three-dimensionally so that it looked natural, and the second is what happens if this character is close to a solid thing like a table, of course virtually. How do you detect this? And this is a non-trivial thing. The inventors devised a certain way that you only use certain characteristic points of the virtual character, which are compared to certain characteristic points of the object, and so you could avoid that on the screen while turning around. This person would walk through a table or a wall. And again, this was found to solve a technical problem by technical means, and the patent was granted. And that ends my presentation. Thank you very much.